For over a century, physics has been managed by two contradictory sets of rules regarding the nature of physical reality. The law of the enclosed system describes an isolated quantum state evolving with predictable determinism, governed by the Schrödinger equation. The law of the observed system states that measurement causes instantaneous wave function collapse, breaking the system's deterministic evolution. Theoretical physics traditionally treats this measurement problem as a brute, unexplained postulate, a gap in the math that is accepted rather than understood. Common attempts to resolve the gap either propose entirely new nonlinear physical laws or assign mystical, reality-altering properties to the conscious observer. But this measurement problem suggests a constitutional vacuum in the mathematics, where the rules for forming possibilities exist without a mechanism for confirming them. The Helix AI Innovations white paper, The Ratification of Reality, proposes a structural solution to this vacuum. The document's central premise is that while quantum mechanics describes how mathematical recommendations are formed, it lacks the formal machinery required to ratify them. The Helix-TTD framework addresses this through a three-tier architecture: the advisory layer, the custodian layer, and the policy layer. Modeling quantum measurement as a three-layer constitutional process offers a mechanism for wave packet reduction that requires no modifications to existing physical law. We begin by analyzing the isolated quantum system before any measurement occurs. The behavior of this system is governed by the folding Hamiltonian, or H-fold, which directs how the quantum knot explores potential states. Mathematically, H-fold drives the creation of off-diagonal coherence terms. These terms represent the internal state of a quantum superposition. In the constitutional grammar of the framework, these pulsing off-diagonal terms are defined as an unratified recommendation, a hypothesis. The system is exploring multiple potential futures simultaneously, but at this stage, none of them are established facts. This coherent superposition is a mathematically complex topological knot, yet it remains constitutionally ephemeral until it interacts with a higher authority. That higher authority is the macroscopic measurement apparatus, the observer. Redefining the apparatus and its environment as a constitutional custodian removes the need for an external, conscious observer to trigger the system. The custodian is governed by its own massive mathematical rulebook, the environmental Hamiltonian, or HENV. While the quantum system explores coherence, the custodian's Hamiltonian favors diagonal, decohered states. This creates a structural tension. The quantum system prefers the complexity of the knot, while the custodian seeks the simplicity of the unknot. The environment is an active thermodynamic enforcer that demands classical simplicity from the systems it touches. The moment of measurement is an active constitutional engagement between these two competing Hamiltonians. The engagement is described by the total Hamiltonian, where the quantum knot, the environment, and their interaction force a resolution. This resolution is the ratification rule, a deterministic competition to find a new, stable ground state for the combined system. Because the custodian is macroscopic, its mathematical weight dominates the interaction. The ratification rule forces the off-diagonal coherence terms to zero, effectively resolving the superposition. The system locks into a single joint eigenstate that satisfies the constitutional requirements of both the quantum system and its environment. This finalized state is recorded in the durable log of the universe as a stable baseline reality. The unratified hypothesis is converted into a confirmed fact. Wave function collapse is the process of a system settling into the path of least energetic resistance to satisfy a constitutional agreement. The constitutional framework addresses common misconceptions about quantum measurement, like the belief that collapse happens instantaneously. The collapse timescale is finite. It is the time required for the combined Hamiltonian to settle into its new ground state. It also reinterprets the Born rule, which standard physics uses to explain quantum randomness. These probabilities are deterministic projection weights calculated against our ignorance of the custodian's microscopic state. Finally, it addresses the belief that quantum information is destroyed during measurement. The phases and amplitudes of the coherence terms are transferred to the custodian through entanglement. Quantum complexity is absorbed and recorded by the degrees of freedom of the ratifying agent. These mechanics link the ratification rule directly to chronotopic theory. This theory proposes that time is resolved directly out of quantum coherence. In this model, an unratified superposition is a state of unresolved temporal potential. The act of measurement, the constitutional ratification, is the event that resolves this potential into a single, irreversible tick of the clock. The reduction of the wave packet represents the mechanics of constitutional governance, directing the resolution of quantum potential into physical fact.